Question number 10, if you see here, then there's a little bit of discussion required before we go for the solution. Read the question properly. The inductance, reactance has been given, that's 100 ohm. The frequency is given, and there are other parameters given as well. The voltage leads the current. That means that's a pure characteristic of RL circuit, we know. Now, based on this, the question has asked about self-inductance. However, a point to be noted, just to calculate self-inductance, the first sentence is sufficient enough. Of course, the second is also required. The reactance given, frequency given, so you can directly apply XL equals to omega times L. And for this much, the remaining information would be irrelevant. So if you do this, the value of XL, 100 omega 2 pi into frequency, when you calculate the value of inductance, in fact, it does not match with any of the given options. So what we do is that, let's see the other way around. Let's just try to change it. The inductance coil has, if I call this as impedance of 100 ohm. Now, what we can say is that on the basis of this data, let's calculate the self-inductance. Now, I've assumed in the second trial this as impedance, all right? So here comes the point. The value of Z, that is given as 100, and that is equal to root of R square plus of XL square. That is case number 1. Together, it also says that the voltage leads the current by 45 degree. That means if I talk about the phase difference, tan 45, that is going to be equals to XL by R. So this equation gives me XL is equal to R. So with these two equations, you can easily calculate the value of XL. And now if you equate this XL to 2 pi FL with the given frequency, which is 1000 Hertz, the value of self-inductance comes very close to 1.1 into 10 raised to the power minus 2 Henry. So we believe that inadvertently the word reactance must have been added. It should be taken as impedance. Now let's go to question number 11. Question number 11 is something like this. Again, the magnetism part. A regular question, you could say there is a wire frame and one segment is in the XZ plane, the other segment is in the XY plane. And we need to calculate the magnetic moment of the entire loop. Let me show you the options so that you can have a fair idea that how are we going to move. This is a regular variety of question where we follow a simple technique that if you really want to calculate the magnetic moment of the loop, so take this as one and take another. What we have done is that I have added two wire segments at the corner. Now here, further what you would do is that the current in the first segment would be taken in this direction so that the loop in XZ plane will be in continuity. And for the lower one, this one, the current will be in this direction, the downward direction, so that, the loop would also be in continuity. So there are two loops. Both have the same magnetic moment in terms of magnitude, right? So that's going to be I into AB. That will be the magnitude of the magnetic moment. We need to write the vectorial form, and you can use the right hand thumb rule. So the total M vector is going to be Mj cap for this one lying in the XZ plane, and for this lying in the XY plane, that would be Mk cap. So here is the magnitude. You can solve it and you would see you would be getting option number 2 as the correct one. All right, now let's go to the next question, number 12. This is from electrostatics, a very short formula based. You could see a 10 microfarad capacitor is fully charged to a potential difference 50 volt that has been given. After removing, you could see it's connected to an uncharged capacitor in parallel. So this is the famous article of common potential, and the common potential is 20 volt. We need to calculate the capacitance of the second. So you must be knowing the formula. V is C1 V1 plus of C2 V2. In our case, the value of V2 is 0 divided by C1 plus C2. Since V2 is 0, that will be eliminated. Now, straightforward, you would get the value of C2 as 15 microfarad. Let's go for the next question number 13. And what does question number 13 say? Let's see.